All right, so today, even though it's a new section, it's almost like part 2 of the lesson you learned yesterday. Yesterday, we learned about rational numbers. I want to give you guys another way of looking at rational numbers, and this is going to help you on your quiz on Friday. I don't know. You don't need to write this down. I don't know that you need to write it down, but it is important. Okay, so it'll be on the video for you guys to go back and watch. All right, so we have rational numbers. All right, this won't be my neatest handwriting I've ever done. Rational and, just on my desk, and irrational. Rational and irrational. But both categories of numbers are real numbers. So we talked about yesterday, there's no such thing as a fake number, right? Okay, you guys zoned in, ready for math today? Okay, I can see it in your eyes. All right? Rational numbers make sense, meaning rational numbers can be whole numbers, they can be integers, they can be fractions, they can be terminating decimals, they can be repeating decimals. Okay, so that's what we looked at yesterday. We kind of worked on some converting. All right, so converting from a decimal to a fraction or from a fraction to a decimal. Let's give some examples of each of these categories. All right, give me an example of a whole number. 4. Can whole numbers be negative? That sounds like a good true-false question. Whole numbers cannot be negative. Whole numbers, think about it. For something to be whole, that has to be a positive value. Whole numbers cannot be negative, but integers can. So integers, somebody give me an example of an integer. -1, -5. Can be a positive number too. 20. All right. Okay, so those are integers. They have no decimal value. They have no fraction value. All right, give me an example of a fraction. 3/5. Okay, 3/5, 1/4. These values are also rational. All right, so yesterday we converted them to decimals by doing long division. Terminating decimal. Can anybody give me an example of a terminating decimal?
0.3.
0.3. It has an end, right? It doesn't keep on going and going and going. Give me another example of a terminating decimal. Anything. 1.9, 1.5. Okay. Again, I could say 1.943, but again, it ends. Give me an example of a repeating decimal.
0.222.
Okay, 0. You could write it 222 with a ... You could say 1.15 with the bar notation over it. Both of those methods of writing it show a repeating decimal. All of these numbers are rational. All of these numbers are rational. So today we're going to focus on irrational. Irrational numbers are decimal values that repeat. All right, so literally all I'm doing now is just kind of making up a number. 6, 2, 4, 8, 9, ... Is there any way for me to predict what my next digit will be after the 9? No. And the ... means that it just keeps on going forever and ever. It has no end point. The square root of 5, all right? And this leads into what we're doing today. Is 5 a perfect square? So I've been telling you guys, you got to memorize your perfect squares. Is 5 a perfect square? So what you're going to learn today is anytime I take the square root of a number that is not a perfect square, it gets really messy, okay? The square root of a number that is not a perfect square is irrational. It is going to be a decimal value that keeps on going and has no end in sight. All right, so I can either describe an irrational number using the square root or as a decimal that just has the ... over it. All right? Okay, so here's some important information. With that in mind, we're focusing on the irrational numbers today. It cannot be written as a fraction. Remember, those decimal values keep on going. You can't write a number over like 10 million, okay, as the denominator, it doesn't work. Irrational numbers cannot be written as fractions. They are always non-terminating and non-repeating. So again, it goes along the lines of it never ends. Just as a reminder, and we just talked about this, a real number is all the rational and irrational numbers. There's no such thing as a fake number, okay? I keep reiterating that. All right, now is this part in your notes, the perfect squares and perfect cubes? Okay, so it's in your video, all right? The perfect squares and the perfect cubes. All right, I'm not going to make you guys write this again because you've already written it in your chapter 9 notes. But you must have these memorized. Remember, on your quiz on Friday, you don't have a calculator. But all of the questions on your quiz are going to operate within these numbers, within this group of numbers. I wrote it specifically, so you don't have to worry about finding the square root of just a crazy high number. Does that make sense? All right? If you don't have these memorized, you do not have a very high chance of passing the quiz. Okay? You've got to know your square roots, your perfect squares and your perfect cubes. All right? I'm not going to recite them because it'll just sound like a chant. Okay? If we just 1, 4, 9. But here they are. Now, we're going to refer back to these in today's lesson. All right? So it'll be good practice for you guys in memorizing them. So my categories of rational numbers, we just talked about this in the last slide. Integers, repeating decimals, and terminating decimals. Okay, so in example 1, I'm going to classify them. You have a section on your quiz on Friday where I ask you if the number is rational or irrational. Point blank. Okay, you got a 50-50 shot at it. At the same time, you're going to have to explain why. So if it's rational, tell me what kind of rational number is it? All right, look at the first number. Yes?
Will there be any perfect squares?
Okay. Point 1, 2, 1, be careful. 1, 2, 1, 2, 2, 1, 2, 2, 2. Now, while you see the same digits, could you bet $1 million on what the next digit is after that?
Yes.
No, you couldn't. There is no. I mean, maybe you could guess at it. All right, now this came straight from your book, okay? So I didn't make it up just to be difficult. This is irrational. This is irrational. I know that it's non-terminating because of the ... I cannot definitively say that I have a repeating decimal, all right? Or I have any kind of repeating pattern. So that number is irrational. You can abbreviate non-terminating, non-repeating. Guys, your reasoning for irrational is the same every time. The negative square root of 196. Okay, so here's where it comes back to, is it a perfect square or not? Can you take the square root of 196? What is it? 14. Okay, so there's your first test at how well you know your perfect squares. The square root of 196 is 14. But now you have to bring down the negative. What kind of number is this? Is it a whole number? No, it is an integer. Okay, so you're going to say negative 14, integer, rational. You know, the sad part is I'll have kids say integer and then irrational. And it's like, oh, you guys knew it was an integer. It's rational. Integers are rational. All right, what about the cubed root of 2? Is 2 a perfect cube? Can you take the cube root of that? No, that number is going to be really messy. Okay, so if it's not a perfect cube, it's going to be irrational. All right, irrational. All right. Your reasoning, you could say it's not a perfect cube, or you know that it's going to be non-terminating and non-repeating because it's not a perfect cube. Okay. What about negative 0.25 with that bar over it? What kind of number is that? Based on your... Okay, so it's a repeating decimal. Is a repeating decimal rational or irrational? It's rational because it is predictable. It has a pattern. So remember, rational numbers, repeating decimals are rational numbers. All right, so what is the category? It's a repeating decimal. This section on your quiz is not going to require a whole lot of work unless you take the square root of a number, okay? And you're able to. All right, what about the cubed root of 15? Can you take the cubed root of 15 evenly? Is that one of your perfect cubes? No. 15 is not a perfect cube. There's no number that can be multiplied by itself. Think of your list of perfect cubes. 1, 8, 27. Okay? 15 is not one. This is irrational. I skipped one. That little pi sign. We'll go back to it. Okay? Not a perfect cube. You can also say non-terminating and non-repeating. Okay? What about this little guy? My pi symbol. Pi is the most famous, yes, things in math can be famous, irrational number. All right? So people actually devoted years of their life to try to divide pi and come to an ending point. Because when you divide pi, when you actually break down pi, there is no repeating pattern to it. And it literally keeps on going forever and ever. You think, who in the world would spend that much time trying to find an end to pi? Well, have you ever tried to just finish a game because you want to see how it ends? All right, it's kind of the same concept. Pi is always irrational for the same reason. It's non-terminating and non-repeating. Non-terminating, non-repeating. Okay? Definitely irrational. Sounds like a good true-false question. Pi is rational. Is that a true statement or a false statement? False. No, I said rational. Okay? All right. Now let's talk about approximating. Look at these numbers. Okay? We're not going to worry about the tenth because we're not using calculators. All right? Well, the tenth, exactly. We'll talk about it in just a second. All right? Approximate the square root of 71. I'm much more concerned with you being able to approximate it to the nearest integer. Okay? Would you agree that all three of these numbers are not perfect squares? 74, 24, and 8. They're not. They're not in your list. They are not perfect squares. Okay? So what perfect square is it closest to? All right? So what I want you to do, and this is the work I want you to show in your homework. I want you to figure out the square root lower, closest to 71, that is lower than 71, and the closest square root that is higher than 71. We're trying to figure out the closest perfect square to 71. So again, this is where having them memorized is going to be really important. You're not going to do well in this section on the quiz if you don't know your perfect squares. Okay? Can anybody raise your hand and tell me what is the next closest perfect square less than 71? I did raise my hand. You didn't call me. All right, so 64. But you can't just say, oh, well, it's closer to 64 then. You got to go on the other side too and see if maybe the other side there's one that's closer. All right, Jonathan, do you know what would be the perfect square above 71? 81. All right, so now you have to figure out how many units is it away from both of them and which one is closer. Well, 71 and 81, all right, this part you can do mental math, but I'm just kind of showing you. This is 10 units away. All right, 64 to 71, how many units is that away? Not 5, but 7. It's only 7 away from 64. So it is closer to 64. So you will say the square root of 71 is approximately 8. Because it was closer to 64, and the square root of 64 is 8. Okay? All right, and like I said, we're not going to worry about the 10th. I want you to get really good at the integers. Okay? I got 8 because 71 was closest to the perfect square of 64. The square root of 64 is 8. Okay? So I'm just picking the perfect square that it's closest to. Now, on this next one, guys, it's negative. Don't worry about the negative yet. Let's just deal with 24. All right? So I want to know, and again, this is practice for us, right? You might know this answer without showing the word, because this one's pretty stinking close to one of the perfect squares. Okay? But let's still show the work so we can get the practice in, okay? All right, I want you to write. I want you guys to try this before I tell you. What is the closest perfect square below 24? And what is the closest perfect square above 24? Go ahead and write it down. What is the closest square below 24? What is it, guys? 16. What is the closest square above 24? 25. Okay? So which one is it definitely closest to? 25. All right, and so just be careful. In your answer, you're going to say the negative square root of 24, because it was negative, is approximately negative 5. All right? Now, this is probably the only time of the year that I'm going to be picky on this little squiggly equal sign. You're going to see that on your homework tonight, too. It does not equal 5 or negative 5. It's approximately negative 5. So that squiggly equal sign is important. You need to practice writing it. All right? Okay, what about the square root of 8? I want you to pick the closest perfect square above and below. Above and below. Again, this is practice for rounding to the closest perfect square. I don't know the square root of 8, but I know it's pretty stinking close to one of my perfect squares that I can take the square root of. All right. All right, so Reese, what was the one below it? 4. Talanda, what's the one above it? 9. Guys, which one is it closest to? 9. It's closest to 9, right? It's only 1 away from 9. Only 1 unit. The square root of 8 is pretty stinking close to the number 3. It's pretty close, right? It's literally 1 away. If I were, all right, I'm not going to ask you to do this on your quiz, but if I were to ask you to approximate this to the nearest tenth, using, again, approximate is an estimate, right? Approximate doesn't mean put it in your calculator. It means I want you to estimate. What value do you think it would be? What value do you think it would be if I said the nearest tenth? So it's got to have 1 decimal place. Would your number be 2 point something or 3 point something? Why is it 2 point something? Because 8 is not quite 9, right? 8 is less than 9. So the square root of 8, yeah, it's about 3, but is it quite 3? The square root of 9 is 3. So what would you say for the 10th? Because it's only 1 unit away, what would your estimate be? Estimate is a guess. I'd say 2.9, right? 2.9. And again, I don't care if that number is exact. Now, if you were to say 2.2, is that right? No. Okay. 2.9 would be my guess. It would be my estimate. But again, we're not worried about the tenth. All right, you're going to be asked to compare on your homework tonight. Which is greater? All right, now, again, can you take the square root of 35? And here's where you're not going to have to write high and low. You're not going to have to do any of that. You're going to estimate, and you're going to need to show work in your notes. All right? Okay, let's see. I'm looking around. Who would know the square root of 35? What would it approximate to? What is it closest 2. Sam?
It would be around 6 below it.
Very good. It would be around 6, right? He says not quite 6, right? Because that's 36. But square root of 35, don't you think that's about 6? Because it's close to 36. Cubed root of 80. Here comes your cube roots now. What perfect cube? Now there's a wider range here of perfect cubes. What perfect cube is closest to 80? What perfect cube?
81.
Now that's a square root. 64. 64. So I'm going to write this down for you guys to look at. 64 is the closest perfect cube below it. 125 is the closest perfect cube above it. So 80 is closer to 64. The cubed root of 80 is 4. All right? So again, I approximated this, but which number is clearly bigger? 6. All right? In order for the cubed root to be bigger, it would have had to be bigger than 216. It's not even close. 6 is bigger. All right? You will have to show work on this, guys. You can't just put a little greater than sign in and say, oh, I did it. No. How did you know? All right? So, approximate the square root of 8. Go ahead and do that. I want you to approximate this next one. If you're not doing this before I tell you the answer, you're missing out on the practice. Okay? I want you to try to estimate the square root of 8. What is it closest to? And then you also know the approximate value of pi. All right? So I want you to go ahead and write both of those. Okay? We just did a square root of 8. What was it? It's about 3. Is it quite 3? No. So that's really important. We actually said maybe about 2.9. Okay? Or what is my decimal value for pi? 3.14. So the obvious winner here, okay, or the greater one is 3.14. Because I know even though I estimated the square root of 8 to be 3, I know it isn't even quite 3, right? It's like 2.9-ish. So 3.14 is definitely bigger. All right. Be careful with your negatives. The square root of 2. What is my high and low perfect square? 1 and 4. So the square root of 2 is closest to 1. But it's going to be negative. It's going to be negative. That's important. Or the cubed root of 10. What are my closest perfect cubes to 10? 8 and close. 27. All right, so this one is definitely closest to 2. So negative perfect cubes. Perfect cubes. Perfect cubes. Okay, so negative 1 or negative 2. Be careful which one is greater. Negative 1. All right, so with those negatives, you've got to make sure the closer it is to 0, the bigger the value. All right, how'd you guys do? Pay attention. How'd you guys do? Hey, stop. Pay attention. All right. We are going to pause here. Okay. The Pythagorean Theorem is not on your homework. And it's actually not on your quiz either. I want you guys to focus on approximating square roots, deciding if numbers are rational or irrational. So I want to go ahead and time out here so we can start the independent practice together. All right, which means homework, okay? I want to work on the homework together. I want this to be a productive time. So now's not time to check out. You've got no option. You're going to do the homework. So let's do it together and get some good practice in, okay?